Hello everyone, myself Vikash Babu. So today I'm gonna explain about my project, Music Popularity Prediction Project. Coming to the introduction part, so the music popularity prediction analyzes the historical data to focus the song success. Like it analyzes over a period of 30 years data to predict which song will be the popular in future. So various factors were considered like danceability, energy, tempo, loudness, balance, and etc. So here we use the data analysis and machine learning to predict which song or artist gonna be the popular in the future. Various applications like Spotify, Apple Music, YouTube can use this project. The main importance of this project is it helps the artist and the streaming platforms to make the informed decisions. Now coming to the research goals. First, it predicts the future popularity of the tracks, artists, and genres. Next, it identifies the key audio and meta attributes which influences the success. Third, it helps the artists and streaming platforms to optimize the strategies. Last, it empowers the music industry with the data-driven insights. So these are the research goals of these projects. Who will get benefits from this project? First, the artists and the producers. So, with the help of this project, the artists and producers can improve the music production decisions. Like, if we take an example, if the in current trend, if classic genre is the most popular genre, then the artists and producers can make more songs in the same genre so that it will get popular as a next the streaming platforms. It helps the streaming platforms to enhance the recommendation and the playlist. So if a platforms recommends the music based on the user's preference, so the many users will start using this platforms and the platforms can gain more money. So at last, listeners discover trending and personalized music. So if a person likes hip hop genre and the weekend artist, so the this model can suggest weekend artist and the hip hop genre both combined, so that the person can like the song and discover more new songs and make the song more popular, etc. So these are the benefits from this project. Coming to the data collection process of this project. So I scrapped this data using Spotify Web API. Then I merged this with the Kaggle data. So I collected two separate data, which is one set of data from the Spotify Web API and another set of data from Kaggle API, Kaggle dataset. After that, I merged this two data set using unique features and then performed the data cleaning process and feature engineering and prepared this data for ML modeling. After ML modeling, I also did ML evaluation metrics, which we'll discuss in the further slides. So now let me give the dataset overview. So there were 2100 data scrapped from the Spotify web API, and there were 30,000 data of various years from Kaggle dataset. So I just merged this two datasets using unique features like um, track name or artist name, etc. So after merging, I got 6,484 unique data, and there were 23 features in this dataset like danceability, energy, tempo, loudness, artist name, playlist ID, genre, release year, and the track popularity, etc. So this down is the sample image of the my dataset. Now moving on to the machine learning techniques, I used various machine learning techniques in my projects for the comparison and for better accuracy. First technique is principal component or analysis, PCA, then clustering, then ARM, Navy Base classifier, decision tree classifier, then logistic regression, SVM, and other ensemble methods like random forest, XGBoost, and bagging classifier. Let me discuss one by one. So first, PCA. It reduces the dataset dimension while retaining the important variances, which improves the model's performance and interpretability. It also helps to identify the most influential feature which affects the song popularity. So by this, we can make the dimensions of the dataset like in a 2D or 3D. Next, coming to the clustering. Clustering, we grouped the similar songs based on the audio features. Like we consider various features like audio features like as I mentioned before, loudness, danceability, energy, etc. So we just group the similar songs in a particular group and then we performed the ML algorithms. So the clustering techniques includes K-means, DB scan, and hierarchical clusterings. It helps to discover the hidden segments and emerging trends in the music. So next, ARM. ARM is used to identify the frequent co-occurring feature patterns, like um, two patterns like high energy and danceable. So it helps to find the two co-occurring feature patterns. Next, it helps to uncover the hidden relationship between two attributes, like relationship between the danceability and the loudness, or energy and loudness, like this. And it provides the actionable insights for playlists and marketing strategies. So this is the use of the ARM in my project. Next, coming to the Navy based classifier. It's a probabilistic classifier used in this model, used in this ML model. So the formula of the Navy base classifier is given as a P of A given B is given equal to P of B given A into P of A divided by P of B. So Navy base classifier is used to predict the binary popularity categories. So in our project, we had a, column called track popularity where we had a scale of 0 to 100 based on the popularity of the song. So what I did, I classified this as a bin like 0 to 50 as not popular and 50 to 100 as a popular songs. So I did this classifier and used as like a binary classifier, which helps me to give the better accuracy. So it worked well with the future independence assumptions. Next, decision tree. Decision tree, as we know, here is a node, a root node. From that, we'll have some internal nodes, and at the end, we'll have the leaf nodes. This is the sample image of the decision tree. So decision tree is helps to create a easy interpret decision rules for the popularity prediction. It highlights the key features impacting the song success. It also provides a visual and understandable classification paths. Like I told, there will be a root node. From that internal nodes, like the classification paths, which are the features having the classification. It helps us to provide a good visualization and understandable images. So moving on to the next one, which is the logistic regression part. So we use this for the binary classification of the track popularity, whether a song would be popular or not. So for this, we used regression model. Next, XVM. SVM is used to classify the songs based on the complex boundaries. I applied various kernels like linear, polynomial, RBF kernels for the better separations. So each kernel have different type of separations, which can give more accuracy than one other. So it's effective in handling the high dimensional audio data. Here sometimes even in my data I have some high dimensional audio data. So SVM could be a better model, but let us move on to the other models too. So this is the separation line of the SVM. Like we can tell the margin. So below the margin comes to the class 1 and above the margin comes to the class 2. So this is the basic idea of the SVM model. Now coming to the ensemble models, uh, we performed various ensemble models like random forest, XGBoost, and etc. So it combined multiple models for better accuracy. Like random forest is combining multiple decision trees, which gives the better accuracy than a decision tree. It focused on the boosting techniques like XGBoost. XGBoost delivered the best overall performance. Like I'll explain why XGBoost delivered the overall performance, best overall performance in the next slide. So from this comparings, we can tell that yeah, yeah, XGBoost has good accuracy and good F1 score, like 0.98. Even though bagging classifier and decision tree has same accuracy and same F1 score, but based on the confusion matrix, like the mixed classification of the true negatives and true positives, like based on the confusion matrix, we can tell that XGBoost is the most best model in my project. Now, Uh, this is the confusion matrix of the XGBoost and the classification report of the XGBoost model. So from the classification report, we can tell that model is performing, having 98% of the accuracy, which is the excellent performance, having excellent overall performance. And the F1 score, which is 90.98, indicates that there is a great balance between the precision and the recall of the model. Coming to the confusion matrix of the XGBoost, we can tell that there is only a 25 mixed classification in overall model. Like rest of others were classified correctly, and here um, 3 and 22. So there were only 25 misclassification in my model. So XGBoost is the best um, performing model in my case. Yeah, now coming to the conclusion part, the predictive analysis can accurately forecast the music popularity. Next, it helps the artist make better popular music prediction choices. It then assists the labels in a smarter investments and promotions. Like the best models, the best music which is popular can use in the advertisements, and which helps in the promotion kind of things. Next, enhances the listener's experience with more personalized playlist. So we can give the personalized playlist for the listeners, which helps them to particularly use the platform frequently. Then it bridges the gap between the music creativity and the technologies. So this is the overall conclusion of my project, and this is my project. Thanks for giving me this opportunity. Thank you.